Very good evening to everyone, and welcome to the NPTEL's ninth live interactive session on the course Engineering Metrology. The course instructor for this course are Professor J. Ram Kumar and Professor Amandip Singh Oberoi, and I am an additional TA Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So in this live interactive session, we will be going to solve some sample problems related to your weekly content, which will in turn help you to solve your weekly assignments. Okay. So as this is the live interactive session, I hope for the interaction. So let's begin. So before going to solve some problems, we will quickly recapitulate what we have seen in the last week content. Okay. So am I audible? Can you confirm? Anyone? Mr. Chandu, Mr. Avinav?
Yes, sir.
Okay. So we will quickly recapitulate what are the things that we have seen in the last week content. Okay. So in last week we have started the new thing, that is the statistics in metrology. Okay. So in this we were studying the use of statistics in metrology. Means how we can use statistics to get the better inferences and the information from the data that we have. So in that we have seen some important steps in the statistics, like collection of data. Okay. First we collect the data, then we summarize and describe that data. And describe data. Okay. And after summarization and description of data, we draw conclusions or inferences. Draw conclusions or inferences based on the data that we have. Okay. So we have in the introduction part of the statistics. Okay. So in the data, that is the collection of data, we have seen the two types of data. One is the primary data and another one is the secondary. So primary data is basically the data that we get from the experiments. Okay. And the secondary data, like the standards we have or the values from the handbook that we use. So that is the this is our secondary data. Okay. So in terms of analytics, if we see these three types, then we can say that the collection of data is nothing but the predictive analytics, and the summarization and description describing a data can be known as descriptive analytics. So, and the stage of drawing conclusions and inferences from the data is known as prescriptive analysis. Prescriptive analysis. Okay. So this we have seen in the introduction part. Okay. Then after that we have seen what is mean by statistic and what do you mean by statistics? Okay. So statistics mean nothing but the variable that we are considering. It can be mid, mode, everything. Okay. So after that we have seen the what is measurement and measurement. Okay. In Measurand and measurement. What we have seen, the measurement is nothing. Measurand is nothing but the value x, or the value x that we are trying to find. Okay, or the quantity that we need to determine is nothing but the measurement. And what is measurement? It is the well defined set of steps to calculate the or to find the measurand. Okay. Generally, the measurand and measurement has to be equal to the measurand, ideally speaking. So, if we can write the measurand, measurement has to be equal to the measurand, ideally speaking. Okay, but what will happen, we will not get the original measurement value. Okay, sometimes we get some error. Okay, like some deviation in that thing, or some less or some more. Okay, that value. Okay, so the difference between that one is known as the difference between the measurand and measurement is known as the error. Okay. So after that, we have seen what is meant by measurement error. Okay. In measurement error, what is measurement error? It is the difference between actual measurement and observed measurement. So after this, we went to see the classification of measurement. Okay, so we have seen the measurement. First that we have seen was based upon accuracy. In that we have seen the two types, that is equal and unequal accuracy. Then the number of measurement, I mean, that is whether it is a single measurement or single multiple measurement. Okay. So then we have seen some other types of measurement like technical and metrological measurement and absolute and relative measurement. Technical and metrological measurement, and fourth one is absolute and relative measurement. Okay. So this is main four classification of the measurement we have covered in the last week content. Okay. So then after that, we went to see the what do you mean by the valid measurement. Okay. And it need to be precise, it need to be accurate, and that one we have seen in the valid measurement. Okay. Then we have seen some terms like uncertainty, that is the estimate of error. In simple word, we can call it as estimate of error, and it includes both what bias and precision. Includes bias and precision. So like, and After that, we have seen some types of error. So in types of error, we have seen the systematic and random error. Okay. So in systematic, the error values will be same and it will come when we perform the experiment same way. So same error values when we perform the same way. Okay. And random error may vary from observation to observation and due to the inability of performing measurement exactly the same way every time. Okay. So we can say may vary from observation to observation, and this is due to inability to perform measurements exactly the same. Yeah, Aman, would you like to say something? Exactly the same way every time. Yeah, Mr. Amar, would you like to say something? Okay. So, sorry, I forgot to mention one thing. After a valid measurement, we have seen some measurement method. So we have seen two measurement method, that is the linear and stable. What do you mean by linear measurement? If the no bias or if the bias is there and it is constant, okay, or no bias, or if bias is constant, okay, then that measurement is linear measurement. Okay. Then after that, we went to see the stable measurement, that is the precision and bias are the precision and bias for any measurement will be the constant across the time. Will be for any measurement will be constant across the time. Then we have seen the error like relative and percent error. Also the type A and type B uncertainties. So, and after that we saw what is data versus information. Okay, data versus information. So what is data? So data is nothing but the collection of values. Okay, collection of. And what is information? When we try to extract something from the data, so that is nothing but the information. So when we try to extract something from the data, so generally the data will be the unstructured one. Generally we see the data is unstructured form. Okay, so in information the data is little bit structured. Okay. So this we have seen in the data versus information. Then we have seen some what is meant by qualitative versus quantitative data. Okay. So this we have seen in the. So the qualitative data generally considers attributes. Okay, and it is the generally the observed one, like whether it is long, short, overweight, underweight, like that. And the quantitative data is the measured one, like we considers values. Like if we are measuring something, so what we are doing actually, we are measuring the data, like we are getting the quantity. So after that we have seen the scales of measurement. Okay. So in scales of measurement, we have seen the two main types of scales, that is categorical and numeric. In categorical, there are two types. One is the nominal and second one is the ordinal. So as the name suggests, nominal, norm means we are talking about some persons or like that, and in ordinal we are talking about the order. Okay. So in numeric we have interval or ration. So this we have seen, and after that we have seen some the difference between the discontinue discrete and continuous data. So what is discrete data actually? The discrete data is the value which have nothing in between. Okay. And the continuous data is the continuous means it has something in between. Like the customers, number of customers, if we are talking about, so it can't be continuous. It can be discrete, like 2, 4, like that we will get. Okay. And generally the discrete data will be visualized or represented in the form of bar chart, and the continuous data will be in the form of histogram. So then after that, in the last we have seen the introduction to the probability. So what is probability? It is the mathematical theory intended to describe chance or randomness or random variation, or in simple word, the chance of occurrence. So these are the all things we have seen in the last week content. Okay. So based on this data, like the content, we will try to solve some samples problem. So moving towards our first problem, the difference between actual and observed measurement is known as measurement error, correction, insignificant correction, none of these. Can anyone tell me? Mr. Chandu? Okay. Mr. Rajesh?
Sir, measurement error.
Okay. Mr. Rodrigue? Okay. So, as we have seen, the difference between the actual and observed measurement is known as measurement error. So it's the direct question. Okay. So measurement error is nothing but the actual measurement minus observed measurement. So this answer will be the correct one. Okay. Now moving to our second option, correction. So what do you mean by correction? So if we are getting any error in our measurement, okay, that is a predefined value. Like we are getting some offset by plus 5 or minus 5. So what we will do, we will correct that instrument, that we will give the positive 5 or the negative 5, and based on that one we will get the correct value. Okay, so that is nothing but the correction. So this can't be the answer. Similarly, insignificant correction, this can't be the answer. So only the correct option here is measurement error. Now, moving towards our second question. A data set that is not precise nor accurate is invalid, unreliable, both invalid and unreliable, or none of these. Can anyone? For your simplification, I am drawing the bullseye. Now, tell me, this first condition comes to anyone?
Good afternoon, everyone.
Yeah.
For me, I think it's both of them. Third position.
Okay. Mr. Chandu? Mr. Rajesh?
Sir, precision, I think.
So this data is precise, okay, but not accurate that much, okay. So this one not precise but accurate. This one and this one is the precise and accurate one. So what they are saying, the data set that is not precise and not accurate. Okay, if the data is not precise and not accurate, we can't process with that data. Okay, so what will be, the data will be invalid. Okay, so we can't relate that data with the output that we are getting. Okay, so we can't we can't draw some conclusions or inferences from that one. So what we can say that the data is invalid. If data is invalid and it is not precise also, and accurate and precise, means there are more errors. Okay, means the data will be will not be that much reliable. Okay, so we will not get the reliable values and the output. So if the data is that is not precise or not accurate, then we call that data as both invalid and unreliable. So moving to our,
Sir, can I know what is unreliable?
Hello.
What is unreliable means?
Hello. Unreliable.
Unreliable means?
Unreliable means the thing on that we can't trust. Simple word. Means if I have a this 10 mm 15 centimeter pencil, okay, and if I am getting the data like it is 16, 17, 18 centimeter, so it means it is not reliable. We can't trust this data because the actual size is 15. Okay, if we are getting 15, 15.1 or 14.5 or 14.8, then we can say that this is somewhat reliable. But if it's going beyond our range, then we can say we can't trust that value. So if you are not trusting that thing, it's nothing but the unreliable one.
Okay, sir. Okay.
Like in simple words, if your friend is not helping you in your difficult time, so we can say your friend is unreliable one like that. We can't rely on him. Okay, in simple words, if we consider the unreliable. So now moving towards our third question. A measurement system is called as stable or linear or unstable if the both precision and bias for any measurement are constant across the time. Anyone?
So stable.
Any other options? So,
Sir, linear.
linear. Let's see what's the answer. Okay. So, in measurement method, we have seen two measurement method. Okay. One is the linear, and second one is your stable. So, what is linear? If there is no bias. Can anybody tell me what is bias? Huh? Anyone? We have seen in the very beginning of this course. Anyone? Mr. Chandu? Mr. Roderick? So, okay, I think you all forgot what is bias. So, bias is nothing but the difference between the average of the measurement value and our true value. In simple words, if you are talking. So, in linear measurement, there is no bias, and if the bias will be, if suppose bias is present, so it will be the constant. So, if bias is present, is constant. Okay. So if the measurement is said to be stable, if it is precise, that is precision and bias. If it is precise and bias, and any measured value or any measurement will be the constant across the time. Okay, with the time, the precision of that measurement will not change. Also, the bias will not change. Okay, precision bias for any measurement will be the constant across time. Okay. So in this question, what they are saying said that in measurement system, both the precision and bias for any measurement are constant across the time. So this, okay. So this condition that I have highlighted in green satisfied by our stable method of measurement. So the correct answer will be the second one, that is the stable. So now moving to our fourth question. The error which varies from observation to observation due to inability to perform measurements in exactly the same way every time is known as systematic error, random error, non-systematic error, none of these. Anyone? Mr. Amresh, Mr. Chandu, Mr. Rajesh, Mr. Roderick. It's the very simple one. If you have studied if you have properly gone through the lecture, that is the types of error, then you can easily answer this question.
Sir, random error, I think.
Random error. So in the beginning, what we have recapitulated, in that also I have told the difference between what is systematic error and random error. So from that also you can recollect and answer this question. Okay. So you are right, Mr. Rajesh. It's a random error. Okay. So in types of error, we have seen. Yeah, Mr. Rodrigue, would you like to say something?
No, sorry.
Okay.
No,
Okay.
sorry.
Okay, no problem. So in types of error, we have seen two types of error. Okay, one is the systematic, and second one is the random. So we can eliminate one option directly, that is non-systematic error. Okay. So the systematic error is the error when the error value is same when the experiments or the measurement is carried out in the same way. Okay. So same error values when carried out same way. Okay. So random error is the error that in which the error may vary from observation to observation. Okay. And that is due to the, like, if the person is not able to perform measurement, okay, exactly the same way the every time, like if I am measuring one sample again and again and again and again, or the same samples again and again, okay. So what will happen after some time? I will get bored and all these things. So I will not do the proper measurement. So what will happen? So I will not be able to perform properly to carry out the measurement exactly the same way as I did before. Okay. So that will produce the random error. So the error will not be the same in the errors, or in another word, the error will be different, okay, in every case. So random error may vary from observation to observation, and due to inability to perform measurements exactly the same way every time. So in this question, what they have said, that varies from observation to observation and due to inability to perform measurement in exactly the same way every time. So this nothing but shows it's the random type of error. So the correct answer will be the random error. Is that clear? Please say yes or no.
Sir.
Okay. So now moving to our next question. Information is something that is extracted from the data. True or false?
True, sir. True, sir.
Mr. Amresh, would you have other opinion?
Yes, true, sir.
True.
True.
Okay, you are right. You are not correct. So the correct answer is true. Why? In the data versus information. What we have seen, data is nothing but it's the collection of values. Okay. And when we take this data and perform some we order it or we do some changes in that one, and we can arrange, and then we can extract something from the data. Okay, we can interfere or we can conclude from that data. Okay, so that is known as the information. Means what are the what is inference or conclusion that I am getting from the data is known as information. So nothing but the way we try to extract something from data. Like if I am having the 10 to 20 temperatures, okay, so I can like for different years, okay, so I can arrange them with the years, okay. So that temperature that I am having with the year is nothing but a data, okay. If I arrange them according to year, then I can see the trend, whether the temperature is increasing year by year or it is decreasing, okay. So that output that we are getting is nothing but the information. So generally the data is the unstructured form, and the information that we get after doing little bit structuring in that. So little structure. So this is the basic deformation. Deformation. Sorry, this is the basic difference between the data and information. So moving to our next question. The attributes in quantitative data are mostly measured, observed, inferred, none of these. Anyone?
Measured.
Measured. Yeah. Any other option?
Measured answer.
You are all correct. Like in the qualitative versus quantitative data, we have seen the qualitative data is nothing but the observed one that we observed from our observation, or it talks about the attributes. Okay, like this is long, this is short, like that we can say in qualitative. But in quantitative data, what we get the actual values, we get the numerics. Okay, like what we are doing, we are getting that values from the measurement, means that are the measured values. So the quantitative data are mostly the measured one. So qualitative versus quantitative. So this talks about the attributes of observed, and this is measured. Okay, these are the simple question. Okay, you will get the similar questions in your assignment. Okay, so moving to next question. The discrete data that is plotted using histogram while the continuous data is plotted using a bar graph. Is it true or false?
True, sir.
It is false, sir. False.
So we have two options. One is true and one is false. Okay. So Chandu has said it's true. Whether Roderick had said it's false. Let's see. So we have seen discrete and continuous data. So what is discrete data? If the values which have nothing in between, and the continuous data, it has something in between. Like I have the number of customer that has rejected the workpiece. Okay, and on the another hand, I have the continuous data like the measurement of one cylinder. Okay, so what I can do, I can plot them. Okay, so like I can have here this at X, this many numbers of customers has rejected this product. At Y, I have this many. I have at Z, I have this many. So there is no connection in between. Okay, there is nothing in between. Like for the X, we have this much value. For the Y, we have this much value. Okay, but in continuous data, like if I plot okay, so I can say like this is the variation on the measurement that I have got. Okay, so actually we can plot a histogram for the continuous data. So generally the continuous data is represented by or is visualized by histogram. Whereas I can't do the same thing with the discrete data. So for that we simply use the bar chart. So the discrete data is plotted using histogram. This is wrong. Similarly, while the continuous data is plotted using a bar graph, this is also wrong. So what is the correct one? The discrete data is plotted using which? How we plot discrete data? Mr. Chandu, Mr.
Bar
Rajesh?
graph.
Bar graph. And the continuous data?
Histogram, sir.
Histogram. So is this statement is correct? Means true or false?
False, sir. False.
Yeah. The correct answer is false. So now moving to our eighth question. The mathematical theory introduced to describe the chance or randomness or random variation is known as. I have statistics, probability, statistical probability, none of these. Anyone? I have already introduced this concept in the very beginning when we were recapitulating what we have seen in the last week content.
Probability.
Okay. Anyone? Any other option? So it's probability. Like what they are saying, they describe the chance or randomness or random variation. Like if I have a coin and if I toss, so what is the chance that I am getting head and tail? So to study that one, they have developed one theory, and that theory is known as probability. That is the chance, then the chance of occurrence also. In simple word we can say. So that is nothing but probability. Moving to our next question. A set of outcomes of an experiment to which probability is assigned is known as set, universal set, relation, event. None of these. Like
Universal set, sir.
okay, we have one option as universal set. So I will give you one more hint. Like I have a coin. Okay, so I am tossing it. So what I can get? Head, either head or tail. So my theory will be like my outcome. Okay, will be based on what? Whether I will get head or tail. Now tell me the answer. Anyone?
Relation.
So I am applying probability whether I will get a head or tail, okay, on that one. So that are nothing but the event that is occurring. So if I am getting the head, that is event. Whether I am getting a tail, that is the event. So the set of outcomes of an experiment to which we apply the probability is known as event. You all. So this probability will be covered more in detail in the upcoming lectures. Okay. So we have one more question. Next question, similar to that only, the probability, and it will be explained in the upcoming content also. So for the time being, you can answer simply like, if a variable will always have the same value, it is known as a random variable, deterministic variable, probabilistic variable, none of these. This is related to your error also. Like from the error, if you know the types of error, you can easily answer this one.
So deterministic variable.
Yeah, you're right. The correct answer is deterministic variable. And why is it deterministic? Can you explain a bit further? Mr. Chandu, Mr. Rajesh, Mr. Amresh, Mr. Roderick.
So you can determine the value. So it is same.
Yeah, because at every time we are having the same value, but every time it is coming different. Okay, so we can't determine that one. It will be the random one. So if it is coming same every time, then definitely we can determine that one. So from the word itself, you can answer this simple question. If a variable will always have the same value, is known as deterministic variable. Now moving to next question. The systematic error causes one measurement to differ slightly from the next. We have already discussed this question twice today itself. So you can answer. Yeah, Mr. Roderick.
Also.
Okay.
False, sir.
Okay. Mr. Chandu, Mr. Rajesh, would you have other opinion?
So false.
Yeah. So we have seen in the types of error, like systematic and random error. So in systematic error, what happens? The same values, okay, we get for the if we perform the same way. Okay, but in the random error, what will happen? The error will vary from observation to observation. Okay, so here what they have said, the systematic error causes one measurement to different. So one measurement to different slightly from the next. This is the case for random error. And they are talking about they are talking about systematic error. So the correct answer will be the false one, because in systematic error, the measurement will not differ slightly from the next one. Okay, in case of random error only this thing will happen. So now moving to our next question. Which of the following statement best describe the relation between a parameter and a static? Parameter has a sampling distribution with statistics at its mean. Or parameter has a sampling distribution that can be used to determine what value is the statistic is likely to have in repeated samples. A parameter is used to estimate the static, or a static is used to estimate a parameter. Anyone? This thing we have seen in the statistics in metrology, introduction to statistics in metrology. Like what is static, what is statistic and what is statistics. So in statistics is nothing but a variable, and if we use a variable to estimate a parameter, so the correct answer will be the second one. The correct answer will be the last one for second question. Now moving to next. This is just again the repetition. The difference between the actual measurement and the observed measurement is known as
Measurement error, sir.
Yeah. The correct answer is measurement error. So appropriate. So next question is appropriate data collection and analysis quantifies the stability, quality, error, or variability of the physical measurement. Like if you are performing some experiments and you are taking that data properly, okay, and you are analyzing it very wisely. So what does it implies? Like appropriate data collection and analysis quantifies the, what does it quantify?
Quality.
Quality. Okay, we have one option as quality. Any other option? Yeah, Mr. Chandu, you are right. The correct answer is quality. So if you have data, okay, and it means if you are properly collecting the data and we are properly analyzing it, so what does it will tell? Like the quality of the data collection or the physical measurement that we are carrying is increasing. Like we can be the more reliable on that one. Okay, like it is improving the quality. So we can say the correct answer is quality. So next question is statistics is the study of quantitative facts, qualitative facts, both quantitative and qualitative facts, or none of these. Anyone? Mr. Rodrigue, I am not able to hear you. You can type in the chat box.
Quantitative and qualitative.
Okay. So in the statistics, what we do, we collect the data, then we summarize that data, and then we draw some conclusions or the inferences based on that data. Okay. So the statistics we can apply when we have the quantitative facts. If it is qualitative, we can't predict that much. Okay. Like we can't pre-process it. Post-process it. So generally the statistics is the study of quantitative facts. So moving to next question. The data points that are collected by actual surveys or questions for a specific purpose and use are called qualitative data, primary data, secondary data, continuous data.
Primary data, sir.
Yeah. Any other option, Mr. Rajesh, Mr. Chandu?
Sir, continuous data.
Okay. So here we are talking about collection of data. So there are only two methods. One is primary and one is secondary. So we can eliminate these two options. So answer lies within these two options. Now tell me.
Sir, primary, I think.
Yeah. Why is it primary data? Because we are collecting it by ourselves. Okay. Like we are not referring any handbook or any standards. Okay. We are collecting that data or the questions for our specific purpose. Okay. Like to carry out the experiments and all these things. We are not referring anything, or we are not taking any standards, or we are not taking that data from any references. Okay, means we are actually asking people, or we are collecting the data from the survey. So this is nothing but the case of primary data collection. So moving to our next question, the error caused. Sorry, is it screen changing?
Yes, sir.
The error caused in the apparent position of the object due to viewing angle that is other than the angle that is perpendicular to the object is known as aberration error, precision error, parallax error, bias error. We have already seen this one in week 3 or week 4's content, where we have seen the Abbe's principle, like measurement, that one. Visibility of scales, readability of scales, in that one we have seen this thing.
Parallax error, sir.
Yeah, Mr. Rodrigue, you are right. Like if I have a scale and I have value this is the true value, okay. And this value I can see if I observe from the other directions, okay. And this value I will see if I view from this angle, okay. The only true value will be I can see when I will be perpendicular to this one. So this observational error coming due to the angle, like if we are viewing at the angle, is known as the parallax error. So moving to our next question. The multiple measurements is the measurement of the same quantity in which the result is obtained from several single measurement in a succession, accession, inheritance, none of these. Like if I have this pencil, I am measuring its diameter here, at means I have like these 10 pencils and with the same diameter, and I am measuring its diameter. So it will be the multiple measurement, and that multiple measurement I am carrying out in which order? Succession, accession, inheritance, or none of this? Anyone? Yeah, Rajesh. Would you like to say something? Yeah, Rajesh. Inheritance.
Sir, I think inheritance.
Okay. So the correct answer is the succession, because I am carrying out that measurement in the succession, one after another. Is that true? Yeah. Because I am carrying multiple measurements of the same quantity, in which the result is obtained, I am getting the result from every single measurement. So that is in succession. So the correct answer is succession. So the next question is the last question. The data measurement which arises from a separate and specific measuring process is called. Continuous data, discrete data, valid data, reliable data. Anyone?
Discrete data.
Yeah, Mr. Amresh Kumar, you are correct. The data measurement that arises from a separate and specific measuring process is known as discrete data. So that's it for today. So we will end our session here itself. So if you have any doubt in the question that we have solved, you can ask. Otherwise, we can end our session and you can leave now.